This final section is our most challenging one. We're going to be using a sentence, a word problem, and converting it into equations before we solve it. So the big challenge here is actually getting the equation that we're using, not just the solving it. But one thing that we're going to learn is that a sentence or phrase can translate into a single sentence, and we're going to look for certain keywords that help us know what's going on. So we see a couple parts of this sentence right here. It says two numbers added together equals 77. We see a second part that says their difference is 11. And we're going to try to turn this into equations now. Two numbers added together. So if we want our two numbers, we have to give them some letters so that we can, because we don't know what those numbers are yet, so we need to give them variables, things we're not sure about, and letters is usually how we do that. So if we said x and y, since that's what we've been using, x and y are our variables, we're going to say that two numbers added together is going to look like x plus y. So let's add those two numbers together. It says it equals 77, so pretty straightforward. We're going to write an equal sign, 77. And we just translated a phrase into an equation. On the other side, it says their difference is 11. Difference means subtract. So when you see the word difference, you think subtract. So that means if we were to subtract those numbers, their difference is, whenever you see is, you're thinking equals. Is and equals mean the same thing. Is 11. We've created two equations now. And with those two equations, we can use the techniques we learned in the previous sections in order to solve the system, to figure out where are both of these true. And now you can start to see a little bit more about why something like this process might be useful. So let's try in this first one to get y alone so that we can plug it into the other one. If we want to get y to be alone here, in order to do that, we need to get the x off the side. So I see that x is being added. I'm going to add a negative x to both sides. Doing that leaves me with y equals 77 minus x, or 77 plus a negative x. Now, using the techniques we learned earlier, that y, or this entire thing since they're the same, can plug in for that y. So we're going to go ahead and try that. X minus parentheses, and we're going to leave space for what y is, equals 11. Inside of those parentheses, we're going to put what y is equal to, which is 77 minus x. Now this is the part that can get a little bit tricky if we're not careful. That negative sign out front, it might be even more helpful to make it a -1, because we have to remember that that negative is actually being multiplied. That -1 is actually being multiplied by everything inside. So when we see a negative sign out front of parentheses, it means we have to distribute that negative to everything within. So I have my x, but then I have a -1 times a 77, and that's going to be -77. I then have my -1 times a negative x, which is going to, negative times a negative is a positive, and I'm going to get 1x, or just x, equals 11. So this step is probably the trickiest one that we actually run into there. Now when I see just x by itself, sometimes it's helpful to write a 1 in front of it, so when I'm adding 1x plus 1x, I think, oh, well, 1 plus 1. So let's do that. I have a positive 1x and a positive 1x on the same side, so if I'm collecting my like terms, they add up to 2x. Still have my -77, still equal to 11. If I want to do something to both sides to get the 2x by itself, I'm going to add a positive 77, because I have a -77, so I add a positive 77 to both sides. That goes to 0, leaving me with 2x equals 11 plus 77 is 88. I want the x to stay but the 2 to go. They're connected through multiplication, so I divide by 2, and I get x equals 44. Just like before, when we solved one of those for y or for a different variable, we can use that to plug it back in. So if I know x is 44, I'm going to take this equation here, y equals 77 minus x, or minus 44. So I replace x with 44, and since those parentheses have only one thing inside, we can actually just not write it with the parentheses if that makes it easier. Y equals 77 minus 44 is going to be 33. If we want to check these answers, we're going to plug it into the equation that we started out with, which is this one right here, the one that we didn't solve for y. And we're going to take x minus y and equal it to 11. So if x is 44 minus y is 33, then the answer should be 11, and 44 minus 3 is in fact 11, so it does check out. The only part that we want to add to this, now that we've gotten these answers, is we don't want to just write this as a coordinate. We want to look at what the question actually wanted. And the original question says that we need to find two numbers that add together equal to 77 and subtracted are 11. And those two numbers are going to be what we got for one of them, 44, and what we got for the other, 33. So our answer, the one that we really care about, is what are the two numbers that make this true? So it's kind of like a little puzzle. This section is going to be broken up into 3 videos, so after you finish this one, go ahead and continue right on to the next video.